Hello my friend, the next chapter is installation in KNX. So now we are going to mention some important points about the installation and see what KNX concern about it. First of all, in a book said that the KNX network is the self. So what is the self? It's a safety extra low voltage network. The permitted voltage range for a self network for AC is below 50 volts and for a DC is below 120 volts. And it is said that no special protection against direct contact is required if the voltage do not exceed 25 volt AC or 60 volt DC. So this is totally safe for human being, this type of voltage. So what's happening and what we should concern about the self network? First of all, the voltage we use in a KNX is 30 volt DC, so it's totally safe. Then each bus devices, I mean the KNX bus devices, as we said, it's a cell. It has the double insulation or safe insulation to the 230 volt or 400 volt AC. Okay, so there is a tight insulation between the KNX and main voltage. Okay, so where we have it in KNX devices, probably we have it in, for example, power supply unit. Then we have the also safe insulation between KNX devices and other network devices, like some devices we use it in telecommunication or signaling. Also we have the basic insulation between the KNX devices and earth. So you can see here there is no any insulation between the KNX devices and the user, okay, because the KNX devices is self and you can work by hand in a safe manner, as we do it in a project. For example, we wire the black and red KNX cable to the KNX connector without using special things. So the voltage we use is 30 volt DC. So how about the insulation? Book also said there is a basic insulation to the earth, as I said. There is a safe insulation or double insulation to other networks, it's 230 volts or other networks, and no insulation to the user side. The self network may not be earthed. So in a KNX we do not earth the KNX cable. I mean, the KNX cable most of the time it has some shield. We do not connect the shield to the earth. Yeah. Cable that are intended for the installation of the main network may not be used for the installation of a TP network. Special things is in KNX only we should use the KNX cable to the connection. About the KNX cable that we used, there is two type of those cable the book mentioned. So the first one, you can use it in a project and put it next to the three-phase main power. Okay, so what it means this type of cable, they have the test voltage for 4 kilovolt AC according to the EN. And the important things, as I said, is they use for the for a project that we can put this type of cable next to the 400 volt AC. But there is another type. The test voltage is 2.5 kilovolt according to the EN, and you can put it next to the 230 volt AC. Okay, so there is two type of cable that we have it. So only you should use the standard cable to connect the KNX devices. We cannot use the Cat5 or Cat6 or other network cable, of course. So here also said we can use it for 1000 meter line segment in KNX topology. The maximum devices, the maximum distance between two devices in a KNX cable is for one line segment in 700 meter, and we can use about 256 devices in one line. Also here the loop resistance, it is mentioned why we need this information, like loop resistance and loop capacitance, because when we want to check the cable if it is evaluated as the KNX standard for the cable, we should consider these 75 ohm and 100 nanofarad per 1000 meter. Anyway, so that's it. Important things in a book said it is not required to connect the shielding of the bus cable to the equioptional bonding bar. As I said, we do not connect the KNX cable to the earth, the shield of the cable, so we do not connect it to the bonding bar. In other protocol, like for example the devices in BACnet, we always connect it to the bonding bar. Anyway, we have the pair of plots, red and black. Okay, a spare wire, the white and yellow permitted use of the spare wire, no connection at all for other self network, so it is possible to use it for self network. The yellow and white, sometimes in an exam they ask, KNX ask it. So the yellow and white, maybe we use it to power up some other devices, some devices in KNX that needs more power. For example, the touch panel. Okay, the touch panel, the colorful touch panel, always they need more power. We use it, we power it up with yellow and white. But in sometimes we want to provide the connection for another line, two line in a one wiring, so we can provide it by connecting the yellow and white. Or as the book said, you can use it for other self low voltage network. Another things, maybe in exam they ask, please make sure that all installed cable are properly identified and marked. You should always mark the cable. Okay, the next important things. Look at the picture, what it said. It said, if the green cover, if the green sheet of the KNX cable is available, you can put it next to the 230 volt AC cable without any distance. There would be no problem. But if the green cable is not available, okay, it means you separate the green cable from the KNX cable. If you want to put next to the 230 volt AC cable, if the AC cable has a shield or does not has a shield, you should always consider 4 mm creepage or gap between these two cable. Okay, so if the green sheet of the KNX cable is not exist, you cannot put exactly next to the 230 volt AC. You should always have some gap between those. Another important thing is if you change the polarity, in connection, instead of you connect the red to the red connector and black to the black connector, you do it vice versa, it won't be a problem. It just the devices is not working, okay, because the device has a polarity reverse check, so you can always change it in a right way and it will be worked. The important thing is a terminator resistor is not required in KNX wiring, so we do not use the resistor or terminating resistor in KNX but we use it in Modbus or BACnet, but we do not use it in KNX. Okay, about the bus devices in distribution board. Okay, now the book said about the electrical board or distribution board and the concerns. The distribution board is used to place the relay actuators, dimmer, mini server, and many other things that we needed in KNX installation for a TP time. And the book said that there are some concern about it. So what are the concerns? We should use the standard distribution board. It means we cannot use the board that is made by the wood or, for example, some things that made from some low quality plastics. We should always use the standard type. Then we should install bus cables with the sheet up to the bus connector. What it means? It means the green cover of the green cover, okay? The green cover of the wiring should be continued to the KNX connector, okay? So, for example, here, yes. Yes, you can see in a picture here in this example the green cable come to the KNX connector. So this is true. It means we cannot use and connect the devices without green cable in distribution board. Another concern is do not install bus devices above main devices, as these could cause the excessive heat development in the distribution board. Maybe in your electrical cabinet you have the contactor, okay? Or you have the, for example, power supply units, not KNX, other power supply units that make the heat, generate the heat, huh? Okay, so you should put the devices like the contactor, the power supply units in a top level of the electrical cabinet, and put the KNX devices in a low part of the electrical cabinet. Even in KNX devices, if you use dimmer or power supply, of course, you should put it in upper than other devices, okay? So if I want to install devices in one electrical cabinet, I can divide to three parts. One part, I put the contactor, the power supply units, for example, between 230 with output 12 DC that make the heat generation. I put it here. I put other devices like the, for example, dimmer in KNX or KNX power supply unit here with less power generation. And I put the devices like fan coil actuators, relay actuators, and so on here with no power generation, okay? Why? Because the heat is working like this. It's coming here, and the heat can leave the leave the electrical cabinet much easier. So here is hot, here is a bit hot, and there is no heat here. But if you put the, for example, contactor here or power supply unit here, then this heat is affecting other devices. If you can keep the devices cold, you can increase the life the life of the devices, okay? It means if I have the, for example, fan coil actuators, I want to work it like 10, 15, 20 years. If I put it in a hot electric cabinet, maybe it work only for 5 years. Yeah. Another important thing is a DIN rail may not be used for earthing. Arresters must have a separate earthing terminal. If you use the arrestor in your electrical cabinet with KNX devices, you should consider some concerns, as I said. And that's it. I think it is enough for now. Okay, the power supply units. First of all, each line needs an own power supply unit to supply the connected bus devices. Remember that. Even in a classical topology, the main line and the backbone line has its own power supply units. Bus devices require minimum 21 volt DC for safe operation. The power consumption of the bus devices can be read in the datasheet. I said it, I think, before, that we should always read the power that the device is used and consider it to select the right power supply. But remember that after the installation, always you should check the devices that put in far from power supply unit and make sure it has at least 21 volt DC, okay? Because if the voltage is below 18 volt DC, then the connection will be stopped automatically by the transceiver in a bus coupling unit. Okay, the power supply unit provides 30 volt DC for the devices. The power supply unit has an integrated voltage and current control and is therefore resistant to a short circuit. Okay, so there is a control. Always there is some LED on a power supply unit. It provides for us some key information. First of all, the power supply unit. In a power supply unit, there is the only place that you should connect it to the earth. Earth connection prevents static charging. Because of static charges, we should connect the power supply unit to the earth always. The 100 millisecond buffer time bridge brief interruptions of the mains, so you can make the shortcut by pressing the reset. There is optional LED on a power supply unit. If it is red, it means overload. If it is green, it means the main voltage is fine. So always we need the power supply to show us the green. And if it is yellow, it means over voltage. So the red is overload, it means you connected too much devices, and red is over voltage. For example, sometimes if you connect the red and black in a vice versa mode, so maybe the yellow is switched on. Here there is two output. One is for most of the power supply unit in a market. One is with the red and black, and one is between yellow and white. Remember that the output of the red and black is with choke, okay? But the white and yellow, there is no choke in output. So if you want to power up another KNX line with this yellow and white, you should always use the choke, okay? You can buy the choke separately from some manufacturers. Okay, as the book said, many type of power supply units from 160 milliamp to 1280 milliamp, it exists in the market. And there is no any information that how many devices you can connect to this power supply. Always you should make the calculation and see what is the power consumption of the devices. Modern power supply units are DIN rail mounted, whereby the bus voltage is available via the bus connector. Some other type have an ancillary voltage output with which it is possible to supply other lines. I said this about the yellow and white. Okay, so about the color of the LED, I said if it is green, it means the power supply is work normally. If it is red, it means the power supply is overloaded. For example, short circuits happen. When you press the reset button, always you do the short circuit, so the red LED will be on. The yellow means an external voltage higher than 30 volt has been applied to the bus device, bus sign. Yeah. Most power supply units do not have an application program. Remember that we don't have a physical address or application program. Some power supply units with the application program exist, containing standardized data point types that allow, example, to transfer malfunction messages and operating data. Okay, so nowadays the power supply unit reports themselves. Okay, for example, the power supply say what is the voltage I use and what is my output and how about my temperature and so on. So the power supply transmits their data on a bus. In this case, you should have the physical address and application program, of course. So here I said the yellow and white, you can connect it to the choke and power up another line. It is possible. You can use 2 power supply in one line maximum, but it should have some minimum distances. Who said this minimum distances? You should pick it up from the manufacturer datasheet, okay? But in KNX, the documents, sometimes it says it should have 200 meter distance. For some power supply units, there is no any distance. For example, new Siemens type, there is no need to any distance. You can put it to each other. Okay. So if you put, for example, 1280 volt, 80 milliamp to the each other, so you have 2560 milliamp to power up one line in KNX. You cannot use more than 2 power supply in one line. But this is not whole of the story. Some devices in KNX has its own power supply unit. It says distributed power supplies. It is interesting. For example, if you use the Synco 700 from Siemens that is used to control the KNX, that is used to control the boiler and chiller and air handling unit based on KNX, okay, it has the connection to the 230 volt AC directly, and it has its own power supply unit. So in that case, you should always follow this table to see how many devices you can power it up with the decentralized or distributed power supply units, because the power supply units that I mentioned it before and we use it for most of our project is centralized power supply unit. We put some power supply in center in electrical cabinet and power up whole of the line. Okay, but in the decentralized power supply unit, it's a bit different. Okay, the current is 25, 40 and 80 milliamp in this case, and you cannot connect so much devices. You can read it by yourself here. So the next important things is to use the flush mount housing that has the screw, because we should connect the bracket of the keypad of the sensor or other devices by the screw. And if you want to install 230 volt AC devices like the actuators, and you want to install the KNX devices in one box, you cannot put it next to each other. Whether you can put it with the plastic barrier between 2 parts, as the book said in a picture, or you should provide the 2 separate flush mount housing. And you should always provide 5.5 millimeter distance between the 230 volt devices and KNX. Remember that these devices, this keypad or sensor, most of the time in KNX, it has the IP environment equal to 20, so you cannot put it in a harsh environment, I mean with so much dust or moisture or whatsoever. So install it in exact environment that the datasheet said. It is important And as the book said, the installation of a bus device in combination with the power device must be explicitly approved by the manufacturer of the bus, so it should be mentioned in a data sheet. Important things about the KNX connector. When we use the KNX connector, it is used to branch cable, okay? Extending cable or connecting cables are realized by means of bus connector. So it is used to connect the devices to the bus. Also, if you want to extend your KNX cable, you should use this one. And you can branch it, okay? Because it has 4 input-output. Bus cable shall only end either at the bus device itself or at the bus connector. So if you are at the end of the bus cable, you should always use the connector. If it is not connected to any devices, removal of a bus device without interrupting the power. It is so important to use the bus cable because bus connector, because when you use the bus connector, if you want to remove some device from the KNX system, there is no any disconnection. Always you drag out the bus connector from the 2 pin. You can see these holes that is going to the pin. Yeah, and it is mechanically has a protection against reverse polarity. You see, if when you put the wire in these two parts, they are totally separated, these 2 polarity. So it is used to branching, extending, protecting and connecting the bus devices. Okay. Nice. Now here it is going to say about lighting protection measure. The KNX TP bus network should be integrated into the protection measures of the main power network. The need for lighting protection for building may be result of the local building regulation. So maybe if the regulation, the local regulation force you to connect the KNX to the lighting protection, so you should follow something, as I said. A risk analysis of the construction in accordance for IEC, a requirement from the insurance company. So maybe the local regulation asks, maybe the standard asks, or insurance company asks. In general, lighting protection measures are required for buildings that can be easily struck by the lighting or to which lighting can inflict heavy damage. These especially include conference rooms, public buildings, and so on. So if you are in a big project, big or very big project, of course you face the lighting protection and you should consider something in KNX. The internal lighting protection consists the most indispensable part of the lighting protection system. It is most significant component is lighting protection exceptional bonding bar. So we have the bonding bar in lighting protection, of course. All conducting elements or systems such as the water supply system, gas pipes here, it is always from all of them should connect to the lighting exceptional bonding bar. Must be connected to the exceptional bonding bar. In the currently valid guidelines, the lighting protection exceptional bonding bar is binding requirement also for active conductor. They must be indirectly connected by means of lighting current arresters. This is referred to primary protection. Remember that for if you want to connect the KNX lighting protection as a secondary protection, always you should first have the primary protection. Okay, so you should have the primary protection, then you can use the KNX protection as a second one. Primary protection achieved by using the for 230 volt 400 volt voltage. You can always follow this as a standard. So bus cable installed between buildings. So between buildings also it is important. If Lighting protection measures have been installed. A special measure must be taken if the installation contains bus cable that extend over more than one building. It is recommended to take these measures even if such a lighting protection systems are not installed. Either a lighting current arrestor should be installed at the next corner of the building, or the bus cable should be installed in between the buildings in a steel or cable duct. In a steel cable duct, which should be connected to a earth on both sides. So if you have this steel duct, you should connect to the earth at the entrance to the building. Okay. In either case, the connected bus devices in a building should be connected to an overvoltage protector together with the line couplers for secondary protection. The bus devices and the overvoltage protector should be mounted apart at a distance of some cable means to make sure that the overvoltage protector is not forced to accommodate parts of the primary protection. Okay, so the next important things is we should avoid the loops, prevention of the loops. Because of the impact of lighting, major surges are generated in a loops. Okay, if this is too far from each other, which can cause flash overs in the bus device. The larger the loop area, the larger the peak surge to be expected. Loops are created when, for instance, both the bus cable and 230 volt cable are connected to one bus devices like the power supply unit. You can see here. As in this case, the power supply unit is connected to both network. Both devices are therefore at risk when struck by lighting, when the light is coming from the sky. However, loops are also created when a connection is made to the water supply system. It is possible also if you use the water supply system, the same. The central heating system, metal valves, the loop is closed by means of the equioptional bar. If possible, care should be taken as early as the planning stage to prevent the creation of loops. Bus and main cables should be installed as close to each other as possible. Remember that bus and main cables should be installed as close to each other as possible. An appropriate distance should be observed from the water supply or central heating system. If line crossing loops occurs in KNX TP installation, it may under certain circumstances not to be possible to properly program the installation. So it is important. Okay. So, as a secondary protection is surge arrestor. What we use in KNX? We use the overvoltage protector with KNX bus connector. So this is some special connector from Dehen company. Let's see this overvoltage protection with bus connector. Yeah. Here you are. Yes. You can see this connector. This is the blue connector. You can see it here. You can connect the red, the black to the plus and minus, and the earth. Okay. So this is a secondary protection in lightning protection. But remember that as a surge arrestor, you should have the primary in your main electrical board and use this one as a secondary one. But where we connect it, you can connect this to the line coupler or power supply in each line. Okay, so each line has its own secondary surge arrestor or lightning protection KNX connector. Yeah. For example, this is a primary surge arrestor. You can see in the book. In a Google search, and this is the secondary one in KNX. Yeah. Okay. Let's continue with that. So, after installation, what we should check? Check whether permitted cable lengths have been observed. Okay, we said 1000 meter maximum for one line segment. We should check. Run a visual check of the marking of the bus cable ends. Okay, we should know the cable is coming from where and mark it. Check installation for inadmissible cable connection. Make sure that the red and black is tight enough in connection with the KNX connector for all of the devices. Number 4, measure the installation resistance of bus cable. Okay, this is something new I'm going to tell you. If you, for regular project we do not need it, but if you, for example, connect 2 buildings with the KNX connector and you don't have a connection, okay, maybe you can use the insulation resistance. And what is the insulation resistance? In insulation resistance, you apply 240 volt DC and measure the insulation, and you should have 500 kilo ohm. Okay, the measurement is carried out as a conductor against physical external, against the PE, and not conductor against the conductor. I mean, you should measure the insulation resistance between the red wire and the earth and the black wire and the earth. But it has a special tools, this insulation resistance. It has a special tools and you should use that. And remember that do not connect to any bus when you want to make this measurement. Your bus devices should not connect. Of course, the connector and the cable should connect to each other, but you should separate the connector from your bus devices, because if you apply 240 volt DC to the KNX devices, they will be burned. Check the polarity. Always you should check the polarity and make sure that the red with red and black with black. Measure the voltage at each bus cable end. You should have minimum 24 volt DC in the furthest devices. Record your test. You should record your test and hand over ETS project to the client. Remember that. And always you should keep in mind these distances: 1000 meter, 350 meter, 700 meter, and so on. Okay, thank you so much to listening to this part.